Very good evening to all of you. With a great pleasure, we welcome all the participants here. Some of the housekeeping rules that we would like to announce is we request all the participants to introduce themselves in the chat box with their name and the organization they belong to, they come from. The second announcement is that we will be recording this entire session as we'll be later on posting the recording and other related material. So therefore, those who may have a concern for the recording may please keep their mic and video off, which is already done as by default as a default option. So the entire event will be recorded. This is for your kind information. Due to the lack of time, we are not holding question and answer session separately in this event. However, please feel free to type your question, queries, comments in the chat box. We will be posting the response to all the questions and queries at a later stage over a portal that we will share the details of the portal at the end of this event. So with this, I would like to request Professor Rangan Banerjee to welcome the participants and the chief guest to the event. Over to you, Professor Rangan.
Okay, thank you, Zakir. Good afternoon and welcome to this event. As you all know, in the Indian context, we are looking at a transition in the transport sector, and this transition, any transition, is potentially problematic. And one of the key things in this transition is to learn from global experiences, as well as to keep a repository of what is there in terms of technology. So whether we look at electric vehicles, we are also looking at the charging infrastructure, and we are looking at the experiences, international experiences. And this is a project which GIZ and IIT Bombay, along with European partners, has been doing, and we are delighted to be here at this event where we are launching the two initial reports. So I'd like to welcome you all, and a special welcome to our Dean R&D, Professor Milind Atre, who has agreed to spare some time to actually be here at this function and to formally release these reports. So we hope most of you in the audience are people who are actually working in the electric vehicle and transport sector, and we hope that you will use these reports, and you will also find ways in which we can work together to see that this transition actually is a smooth transition, and a transition where we can have cost-effective electric vehicles in the future. So with this, I would like to then pass it over to Professor Milind Atre. Zakir, is that the next sequence of things? Zakir?
Sorry, yes. I was on mute. So just to add to this additional information to this study, so on behalf of German Federal Ministry for the Environment, Nature Conservation and Nuclear Safety, BMU, the Nationally Determined Contribution Transport Initiative for Asia, NDC TIA, is a joint project of 7 organizations with the engagement of China, India, and Vietnam. This particular study is being carried out under this initiative in close collaboration and under the guidance of NITI Aayog. As Professor Rangan already mentioned, it is a consortium. This activity that is being led by IIT Bombay, and we are having 4 reports that are being released out of this project. The first 2 are being released in the event that is being conducted today, and the other 2 reports will be released in the future. We'll talk about little more about that at a later stage. So thank you, Professor Rangan. Now we have a keynote speech by Professor Milind Atre, Dean R&D IIT Bombay, who has kindly agreed to release the reports. for this event. So I would request Professor Milind to take over the floor. Over to you, Professor Athre.
Thank you, Professor Zakir, and thank you, Professor Rangan Banerjee. I'm sure I'm audible. So good afternoon to everybody and welcome to all the dignitaries from India, abroad, from other institutes, all the professors, all the invitees, and my dear students. Very good afternoon to all of you. And on behalf of IIT Bombay, Director, on Deans and other professors, I welcome all of you. And first of all, I congratulate all of you for taking up such an important activity of coming up with such a report, which I believe will be the base for future research on this topic. In brief about IIT Bombay, I will talk and then I'll come to the electric vehicle. So IIT Bombay is definitely a vibrant ecosystem right now for teaching and research. And now we got a business incubator, we got research park, and got a very important activity of coming very close to industry. And our research would like to focus more on our industry side, more on applied side, more on policy making side on the Indian context. And therefore, we are just not an academic institute, but we would like to focus more on applied problem related to society around us and related to world around us. We got more than 10,000 students, 200 postdocs, 750 faculty members. And really speaking, we got almost all the technical specializations here at IIT Bombay. Talking about this important meet on electric vehicles, of course, the government of India has initiated, and this is growing with the government side, the stress that is given on electric vehicle. India has all advantages and of course some disadvantages also. And we got a very large country, therefore a lot of inertia to adopt such change of technology. As Rangan pointed out, yes, change of a technology is not going to be that simple. But we said the same thing when we adopted CNG for our vehicles, and now everybody seems to be comfortable with CNG. However, we know that electric vehicle are going to come and are going to stay here because it will solve many problems for us, although the problems solution possibly would be gradual in nature. But with regards to pollution that we have, with regards to oil dependency that we have, with regards to even foreign exchange that we have to face all the time, electric vehicle will, with grown up technology in the Indian context from India with the help of all other nations, is here to going to stay for the after let's say 5 or 10 years in Indian context. We got a very young population. Every young population, we had middle class people earlier and no vehicle were there in the family. But now we got at least 2 vehicles in every family of around 500 million middle class. And therefore the young population, we need 2-wheelers, 4-wheelers. At the same time, this young population require IoT, they require efficient devices, they require mobile apps, the very mobile app savvy generation. And therefore, I'm sure that the electric vehicle are going to make change in Indian context. At the same time, we talked about inertia of changing infrastructure, the cost associated with this, the cost affordability now, similarly electrical production that we have and possibly renewables here to come. This is what will make this technology a very important one in the time to come. I'm very happy to note that under this study, under this NDC TIA India component, the study integration of electric vehicles, charging infrastructure with distribution grid, global review, India's gap analysis and way forward is very, very important. Is very focused on analyzing overall environment related to EV charging infrastructure and its grid integration at international and national level. As Rangan pointed out, I'm sure the international experience is going to help us in the Indian context. And here we are ready to learn from the international experiences. And this will provide recommendation. The study will provide recommendation for seamless adoption of EV charging infrastructure and its grid integration in the Indian EV ecosystem. These recommendations, I believe, will be used by key stakeholders in India, including policy and regulatory agencies, DISCOMs, EV and EV charging OEMs, energy operators, think tanks, etc., etc. This study, very importantly, was the collaborative work led by IIT Bombay, along with Florence School of Regulation, Technical University Denmark, Cardiff University UK, and IIT Comillas Spain. The specific study, this study focuses on EV charging infrastructure, related policy and regulatory measures, grid integration of EVs, and the way forward for smooth EV adoption in the Indian ecosystem. The study has used a combination of desk research, critical review analysis, bilateral consultation, with various stakeholders and consultation workshops to identify and recommend national and state-specific interventions that can be sandboxed for the use by regulators, policymakers, DISCOMs, and other people. I really congratulate the initiatives by this NDCTI India component and the team and IIT Bombay professors and all the involved people. Of course, we require batteries also with these, and we actually have to go away from possibly lithium batteries to aluminum battery in the time to come. But I'm sure that this will come and this will follow with this. I believe in this study there are 4 reports to come, out of which 2 reports, fundamentals of electric vehicle charging technology and its grid integration, that is report number 1, and international review of electric vehicle charging infrastructure and its grid integration, that is report number 2, are getting released today. IIT Bombay is very proud to be associated with this work with all of you, and I'm sure these reports will find a base to do further research work in these themes and possibly come up with policies and planning for adopting EV charging methodologies in India. So I'm very happy to release these reports, and may I formally say I hereby declare the release of these 2 reports on this study. Congratulations to all of you. Thank you very much. Zakir, I'm done with this.
Thank you, Professor Milind, for very insightful words on this very important topic and development that is happening very rapidly across the globe and in India as well. Thank you so much for joining us and releasing the reports and enlightening us with your words of wisdom. Thanks a lot. So the reports are available on the links that are being displayed here and are being shared in the chat box. These reports are available on the 2 independent links, as you can see here. One is the top one from IIT Bombay side, and then there is the other one, this from Green Mobility Library. So you can click on the links and access the reports. The reports on this Green Mobility Library org is available on the bottom side. You have to really look for the download option there. While as for the these links that are provided from IIT Bombay side, I think you can directly hit the link and get the access to the 2 reports. And the links for both the reports have been shared in the chat box. You can go there and access the 2 reports. So with this, I would like to now request the first presenter of the presentation on the reports, by Professor Pablo from IIT Comillas, who has been part of this, who is part of this study and has actively participated in the study. So with this, I would request Professor Pablo to take over and go ahead with this report 1 presentation, which I'll be sharing from our end. Over to you, Pablo.
So good afternoon, and thank you very much. So for me, it's really a pleasure to serve as presenter of this first report, where, as we previously mentioned, I mean, it's the group from IIT Bombay, led by you, Zakir, has done a very great work, and where I humbly participated as advisor for it. So please go to the next slide. So basically, the document is structured in 9 sections that when you download the document, you can check it. And for the sake of simplicity, in this presentation, we will basically focus on 5 most relevant topics. First, the introduction to EV charging. It compiles half of the document, which is sections 1 to 4. Then we will talk about interoperability, which is about the IT technology behind the need of the charging systems. The integration of electric vehicles in the networks, which is, let's say, a coin with 2 sides. It could be a challenge in the first initial steps. However, it will become a clear opportunity in the future as new services can be provided. And finally, we will talk about, let's say, smart charging, which is something basically required, but this smart charging system, which is based on IT technology, will certainly require some cybersecurity analysis. Next slide. So basically, there are, let's say, three major alternatives for battery EV charging, as you can see in the scheme on the top, where basically we will have cable-based conductive, we have wireless options, and we have battery swapping. Of course, all of these three alternatives are real alternatives and are being nowadays, most of them technology ready, but each have its specific application. For instance, 2- and 3-wheelers, which is something really common in India, or even car-sharing platforms all over the world, I mean, will benefit from these battery swapping alternatives. If we talk about public transportation or heavy transportation, maybe wireless transportation would be a good option. And of course, for any of them, we always will have as a backup this cable conductive idea. So the other relevant issue is about the speed of charging and the power transfer that we have. And for that, we have some basics definition that we need to know in this first presentation, which are the different levels defined by the SAAE, where basically we have levels 1 and 2, basically associated with the alternating current charging, which is a slow and medium charging. And then we have DC charging, which is level 3. These levels 1, 2, and 3 will be something that we will recall over this presentation and the future presentation. So next slide, please. So basically, in this slide, we have, let's say, all the different connectors types that we have in all the different regions of the world. On the top, we have the ones for alternating current, and on the bottom, we have the DC. It is well known that these different standardization has been, let's say, very proactive from the car maker side, not really from the regulation. However, nowadays things are a bit changing. You know, here you have the CHAdeMO one, which is something that has been developed in Japan. And due to the, for instance, the Nissan Leaf, it's a best-selling EV car. It is trying to enter into the different markets in the States or in Europe. However, let's say the new, EV commerce, for instance, Volkswagen, they are really pushing towards the CC S2, which stands for Combined Charging System 2, which incorporates both DC on the down and AC on the top. So this is the one which is, let's say, the winner that all the different regulators, at least in Europe, they are pushing towards. Next slide. So, but in the field of standardization, it is not only required the connection, the electrical connection between the socket and the plug. There is a need of a new layer, which is the interoperation. And this is explained in chapter 2. And for that, we need to cover, let's say, the whole umbrella of EVs. You have on the left the DSO and the electric and the power system. We have in the middle CPO, which stands for charging point operator, which is, let's say, acts as an aggregator of different, for instance, in the parking slot or whatever. And then on the right-hand side, what we have is the electric vehicle supply equipment, which is EVSE, which, let's say, collects all the inner side of the charging pole together with the EV itself. There is a large list of standards. I mean, in this report, there is a very interesting review and critical review of all the standards. The standards cover not only the energy flow and the definition of connectors, but also the interoperability, but also the layers required for safety, which are, let's say, ingresados and for security. So there is a massive number of standards that, I mean, if you check the report, they are well organized and categorized. Next slide. But I mean, these standards, they need to cover not only the physical and the IT side, but also there is let's say, the business layer that basically unlocks the possibility of introducing additional services. So this issue of charging will be attractive to newcomers, and we can make a business out of it. So this is studied in chapter 4, and here you can see a picture where it is more or less similar to the previous one. However, here we introduce, let's say, new players. These new players are, let's say, for instance, the EMSE, which is the electromobility service provider, which is some, let's say, external, I mean, they don't know anything about, let's say, volts or amps, but they want to make business of the aggregation of the management. But for that, we need to have, let's say, an open platform, and this open platform where all the different stakeholders can share the data of where are charging the different vehicles, the size, etc. This is what we call the clearinghouse. What, let's say, we can access to a massive information and open massive information of. Next slide, please. So basically, the alignment of all the previous standards, what they need to answer is to the need that if I am an electric vehicle user, I can, let's say, charge my vehicle whenever I want and wherever I want. But for that, it is not only within the country boundaries, but for instance, within a region, could be Europe, could be Asia, but you can move with a vehicle, let's say, more than 1,000 kilometers in the next few years. So for that purpose, as it happened in the past with the mobile roaming, we need to unlock the supplier and we need to unlock the countries. And for that, policymakers, regulators needs to do, let's say, a very big effort in trying to make this coordination happen. Next slide. So basically, another big part of the report studies the opportunities and the challenges that we are facing currently in the distribution network with the integration of, let's say, massive amounts of electric vehicles. And for that, very important, two things. One, this is an opportunity and this could be a challenge. And second, we have, let's say, electric vehicle as an important source of flexibility. So here, flexibility is the key word. And to achieve flexibility, we need to aggregate. Okay, see, so we have aggregation and we have flexibility. So in the picture now, what you can see is the different, what we call indicators that basically can be for an electric vehicle, both charging, let's say, as a load or discharging. So injecting back power into the network, which is generator. So here, there are, let's say, different ways to monitor that or to characterize this. One is based off long-term indicators, for instance, voltage, for instance, increase of peak load or energy losses. We have other short-term indicators, for instance, flicker effect or the introduction of harmonics into the system. And finally, how these may affect the reliability or continuity of supply. Next slide. So as an example for that, we have here, let's say, the case of an imbalance. Basically, if you have a feeder where you have different phases and I mean, they are connected in the low voltage, so you decide to connect them, or there is no management of the load, so many of the vehicles are connected in one of the phases, it will provoke voltage imbalances, and this will increase the energy losses. This will provoke maybe some tripping of protection devices. So this can be easily solved by introducing a smart charging system. So here you see in the figures, you see the three phases, A, B, and C, where in the light green, you have the dumb connection. So nobody does nothing. And in the black lines, you have the coordinated control. So you can easily see that in a very specific example, you can clearly reduce the power consumption peaks, benefiting, let's say, the power system itself. Next slide, please. So in another big section of the report, which is chapter 7, we have a review of the additional business associated with the aggregation of electric vehicles to procure this flexibility. So here we have as a V2X service provider, services to the DSO such as congestion management support, services to the transmission system operator to help control the frequency, for instance, in weak power systems, or services to improve the integration of renewable generation, such as, let's say, basically the distributed PV in residential areas. Next slide. So for the previous V2X services to happen, smart charging is basically required, incorporating different control strategies that basically depends on the service you want to provide. You can talk about centralized or decentralized. We can talk about hierarchical coordination if different services needs to be provided at the same time, or local strategy if, for instance, we want to integrate with a PV system. In any of these schemes, setting an adequate tariffs for final consumers to react properly is really important. And this is something that, let's say, aggregators together with retailers will be working on. Next slide. So basically, any tarification that or a strategy should always consider the effect on the critical element that we have in this flexible load, which is the battery. Basically, what we do is analysis, or what the review that we've done is basically based on different variables. Can be calendar or cycle based, and could be like ambient temperature or the number of deep cycles that we do to the battery. These variables, of course, will depend or will be clearly affected by the type of service. So for instance, one of the case studies that we'll present later, which is the frequency control, I mean, there is, let's say, little reaction or effect in the battery. However, there are others that requires, let's say, deep charging, and this, of course, will have a negative impact on the battery life, which at the end affects the cost of service procurement. Next slide, please. So basically, one of the things that are also included in the report is some couple of case studies where we try with a very simplistic but representative analysis, let's say, understand the final behind or the electrical things behind the EV charging. So for that, for instance, here you see let's say a feeder where that's a representative feeder where we connect in the low voltage side, let's say, different levels of EV. What will happen? So next slide, please. So basically what happens is that if we do dumb charging, we see that the higher the number of electric vehicles, which is in the x-axis, the lower the voltages across all the network. And in the figure on the right, the higher the energy losses, almost 3 times higher. Remember that this is current squared the resistance. So these are things that we should consider because we have designed the network, the distribution network itself, with some, let's say, protection systems that we need to consider and some cost analysis that we should also consider. The second case study, next slide, please, basically studied the possibility of using the electric vehicles to contribute to control the grid frequency. This is very important in the case of weak systems, islanded systems, or even islands, where we need, where we have, let's say, high variation of the frequency. For that, if we use smart strategies, we will have really positive effort. Here you see the frequency variations in a day in both figures. In orange, we have the current situation. And if we use electric vehicles to support the frequency, we will see a very stabilized value, which is the dots in blue in these figures. Next slide, please. So the final section of the report, which is, let's say, for me, it's really important because that's very novel. It's a very novel topic. It's the topic of cybersecurity, which, I mean, we, let's say, using the electric vehicles with the smart charging systems, we realize that we need a smart charging. So for this smart charging, there are different, let's say, communication layers that we need and data that we need to take care of. So for that, in this section, there is a, let's say, a very thoughtful review of all possible affected agents, the DSO, the position satellites, the vendors, anyone having the information of your car moving around, and the different types of cyber attacks that may appear, and the vulnerabilities that we need to tackle. So that's a very important work. And to finish, next slide, please. Basically, in summary, I think that this report aims to be, let's say, a reference for electric vehicle charging infrastructure, both the concepts and the application thing. It is very important to bring the attention of the need of standardization. Standardization is the key to unlock the possible services that may, let's say, activate the electric vehicles in the system. And for that, smart charging is a must. And cybersecurity issues and the participation of aggregators are also the relevant topics. So this is it from my side. Thank you very much.
Thank you very much, Pablo, for giving the insights into the report 1. And of course, there are much more details provided in the report 1. Thanks a lot. Thank you, Pablo, for presenting this insightful presentation about the report 1. So now we will move to the next presentation, which is about report 2. A very good evening to all the participants. Again, this presentation will provide some of the insights into the report 2 that we have documented over more than 300 pages, where we analyzed it, the experience, the learnings from different countries, EV-rich countries across the world. Try to document very important information about the charging infrastructure, it is grid integration, key learnings and experiences that these countries have experienced over past several decades, and also that provides a basis for how we can actually tap in and utilize this experience that these countries have already gone through in integration of electric vehicle charging infrastructure to the grid. So these are the broader topics that are covered under this report. These target countries are, in addition to the global infrastructure status, we have analyzed it in great detail. These 8 countries, that is UK, USA, and under USA we have analyzed it in detail separately California because of its EV-rich state. Netherlands, Germany, Denmark, China, Norway, and Sweden. So these countries are, in addition to the global status, these countries have been analyzed to a very great detail in this report. We covered EV policies, EV demand, EV infrastructure, charging infrastructure, and grid integration of electric vehicles, where we talked about technical regulations, EV tariffs, EV integration with the grid, with the distribution system, smart charging, grid support services, ancillary services in detail, how electric vehicles can be used to increase the renewable energy integration, how EV and RE can go hand in hand in integrating to the grid, virtual power plant concept, and many more details are provided under this subsection, subtopic. And more importantly, we have provided a list of a variety of case studies, which include demonstration studies, which include the commercial implementation studies, pilot projects that different countries have undertaken to analyze, investigate, and understand different dimensions of this electric vehicle charging infrastructure and its grid integration. So looking at the broader picture of the electric vehicle charging infrastructure, you can see that the charging infrastructure is being rapidly added to the grids across the world, similar to the renewable energy. This is what has been experienced by renewable energy in the beginning. Rapid increase, of course, that is still continuing, And similar trend is being seen now by this electric vehicle charging integration with the grid, with the more and more uptake of electric vehicles. We can see here around 7.3 million chargers have been added by 2019, and which is actually 40% addition compared to 2018. Out of this 7.3 million, majority of the, in terms of numbers, not in terms of the power capacity, in terms of numbers, 6.5 million chargers are private chargers. And we have here for this classification divided them into two categories. One is under 22 kilowatt and the other is about 22 kilowatt. So this is the public charging infrastructure. You can see here China, as expected, is dominating the overall charging infrastructure, public charging infrastructure as well, followed by other countries, particularly Europe and different countries in the Europe and USA. Out of this total 0.4 million fast chargers, what we have noticed, as we'll actually mention in some of the other slides as well, there is a trend towards fast charging, rapid charging, ultra rapid charging that has been experienced over past 4 or 5 years across these countries. There is a strong focus on going beyond fast chargers and going to the ultra rapid chargers in public charging space. But in general, as of now, most of these countries have around 80% of this fast charging infrastructure when it comes to public charging space. So these are the countries here that we are talking about the charging charging infrastructure status. UK, US, Norway, Sweden, China is having the highest number of these charging points connected to it. And one interesting point is, China, which has started, of course, little late than what these European countries and USA has started. You can see that share of these high power chargers is actually very high, significantly high. This is the EV charging infrastructure these countries are experiencing or having at the moment. And in terms of number of EVs, European target is 10 EVs per charger. You can see the status of different countries. UK is exactly matching that target, European target. And some countries have even higher. For example, Sweden, Netherlands have better, much more, better charging infrastructure than what is the target, European target. Except that Norway, which is having higher number of EVs than than the desired target number of EV charging infrastructure. And these are the right sides. This slide is actually provide the number of operators that are with more than 3,000 public charging connectors by region. China, Europe, and US. Europe is actually leading in terms of the number of players, but down the line we are expecting China to overtake that as well. Number of operators with over 1,000 public fast and ultra fast charging connectors. China, Europe, US. Europe is leading in terms of the number of players that are active in these in this space, charging space. So annual, we also try to cover this, how the electricity demand fares in this overall energy consumption scenario. And you can see here, so different segments of these electric vehicles. Cars actually take the major share of the electric vehicles, cars, buses, vans, trucks. And this is the year. You can see as we move forward with the years, the electricity demand increases more and more as expected. And cars actually take the major lion's share of this total electricity demand. So even though the total electricity demand or energy demand consumption by the electric vehicles is relatively going to be of a lower percentage, however, we have to understand the power, the load, the demand that these EVs would actually add to the electric grid is going to be significantly high actual power rating, and therefore the distribution system operators will need to actually readjust their network to accommodate this EV charging infrastructure as we move forward in this journey. UK, we have noticed it is quite actually active in this fast charging space when it comes to public charging. They are having added this rapid that is 23. So different countries have different classifications. So we have highlighted that. Rapid in UK classification is 23 to 99 kilowatts. So rapid, ultra rapid chargers are being added significantly over the past years, and these fast chargers at the moment actually have the dominance in the overall charging infrastructure in UK. As far as integration is concerned, they are also actively integrating these electric vehicles to the grid. There is a set procedure for electric vehicle charging connection, and then how it can be connected to the grid, and there is the assessment of existing margin if the charging this household is having, if the charger is being put at the house, and also in the other private space or the public space, that electrical infrastructure is being first inspected, and then it is being decided whether there is a need for grid upgradation or not. Then accordingly the decision is taken, and the connection is granted, approval is granted to the customer or CPO. So what we also noticed is UK has created this publicly accessible map where you can see the entire distribution system network with the margin that is available under different distribution transformers. That allows the customers or the players who want to put up the charging infrastructure to decide to take an informed decision on where to add the additional charging infrastructure into the grid, into the network. And so therefore there is a lot of transparency when it comes to the data being shared with the public in UK. So as you can see in this chart, so fast chargers actually add up to around fast, rapid, and ultra rapid add up to around 80% of the charging infrastructure in public space. When it comes to policies, they have very promising policies. Some of the very interesting schemes you can see here: electric vehicle home charging scheme, which is supporting 75% contribution to the cost of one charge point and its installation at the residence. Similarly, there is another scheme, on-street residential charge point scheme, which provides 75% of the cost of the installation on street charging points. Modification of building regulations, which mandates this inclusion of EV charging points in these buildings. And then similarly, this guideline requires rapid charging 50 kilowatt for all non-residential developments with 10 or more spaces. So there is a very strong push towards adding this charging infrastructure into the EV ecosystem in UK. And you can see that integration with the energy market is also happening in parallel with the development of this charging infrastructure in the country, in UK. The other important focus that we noticed in UK is on smart charging. So recognizing the benefit and the potential that smart charging can actually bring into this EV space, EV charging integration particularly, not only to the customers, but also to the utilities, distribution system operators, and the grid operators. There is a push for this smart charging, as you can see here. There is a draft regulation already in place that is talking about the smart charging dedicatedly. They have also laid out these policies for rollout of smart charging in a phased manner. Publicly accessible, this draft specifications has been released for the smart charging. Different smart charging architectures have been proposed. However, irrespective of all the pushes for the smart charging, the customer is given the central focus here. They still reserve the right to override the smart charging control decisions that the respective player utility would actually play when a customer participates in the smart charging. So therefore, recognizing this importance of the smart charging, there is a push for smart charging in UK and other countries as well. Coming to the US, we have these ancillary services. So in addition to the charging infrastructure that I already mentioned, there is this a bit advancement of going beyond the primary application of EV charging, that is charging the battery of the vehicle. So here we are talking of interaction with the grid, how we can tap this underlying storage, which remains unutilized for most of the time, how we can tap into that storage and benefit the grid and help the grid to have accommodate more renewable energy integration and have more stable and secure operation. So these ancillary services are actually being procured through these electric vehicles which participate in this market, where the electric vehicles above 0.1 megawatt aggregate capacity can actually participate in this energy market and support the grid. Similarly, this in case of ERCOT, there is this interesting pilot study that has been done where these electric vehicles participated in this regulatory services for the grid operator here, and you can see that different, particularly in this time span to address this peak demand, the prices have been actually more customized accordingly, and this QSC, qualified scheduling entity, is actually participating as an interface between the grid operator and this fleet aggregator, or the EVs, you can say. It is somewhat similar to QCA that we have in renewable energy integration in India, which is actually a mediating agency between the grid operator and the electric vehicles or aggregators, which help in participating these electric vehicles in supporting the grid, providing services to the grid. And you can see some of the revenue calculations or the charge calculations are provided in this table, which help us in understanding that how this can be useful to all the stakeholders that are taking part in these grid support services. The other interesting example is this California case, where these electric vehicles are being used or utilized to address this duck curve issue with solar PV integration. So here you can see that time-based EV tariff is actually being introduced, where these electric vehicles are being used. You can see here 3 to 9 p.m. or 4 to 9 p.m. precisely are being actually addressed, being used to address this duck curve issue. For the locations with these different EV chargers, 10 EV at least chargers, they can participate in it. They will get the benefits, but however, they have to, give a mandatory this agreement that they will be participating in shifting their load when it is as and when it is required by the grid operator. So there are a spectrum of these activities or support services that come out of these batteries or storage that underlies under the electric vehicles. This is another interesting case study that we have analyzed in this report. Is what this case study does is, it is this PG&E utility which has done this case study across different utilities. It has looked into the accuracy of the meters which are provided within the charging hub, that is charging station. So we have to understand one metering will be by the utility that is there, but however, within the charging station, when they charge the customer EV user, they will charge them based on that metering. That metering comes under the purview of the CPO. So what this study did is they tried to analyze the accuracy of those meters which are provided under the charging station. And the criteria was that there should be maximum of 2% error in the measurement. As you can see here, these are the different distribution utilities. Person submitter is passing this 15-minute interval test. So over 15-minute measurements, only around 16% have actually passed that accuracy test. There is none of these meters which has passed the accuracy test under other the utilities. Similarly, in this daily interval test, you can see here 31% have passed this accuracy test under PG&E, while as none of the other utilities which are connected to these charging stations, connect to other utilities, have actually passed this test. This actually brings in a very important aspect that there has to be standardization, quality standardization of this metering, because otherwise what is happening is this inaccuracy of the metering is being, the burden of that is being actually transferred to the customer because of the inaccurate measurements that are happening with this. So these are the different actually reasons that have been cited as the reason for the inaccuracies. Charging station submitter reading the meter itself, the Wi-Fi internet connection that is actually broadcasting the readings, data processing by the vendor which actually supplies the data to the utility, and utility intake and processing. Different actually stages have contributed to these errors under this study. Coming to the Netherlands, very active country, a dynamic country in EV charging. When it comes to EV charging space, they have different schemes which are encouraging, which have encouraged in the past and are being encouraging to adding up adoption of more and more EV charging space in the system. Grid integration also, they are quite active. There are various players, for example, Vattenfall, which participate in these regulatory services, energy market, and help in more integration of the renewables in the country. The other important aspect is that apart from the commercial regulations, that is tariff part, they are also very active when it comes to the technical regulations, that these bidirectional chargers or unidirectional chargers must actually comply with these grid code regulations, should have the capabilities, should be complying with these grid code regulations, which is very important when we have higher penetration of EVs. This has been the case with renewables also. So therefore, it is very important that these issues are tackled in the beginning, so that they do not become an issue at a later stage. Germany, again, one of the very active country in adding up charging infrastructure and integrating that with the grid. You can see here this climate action program 2030. The target is having these 1 million charging stations by 2030. All petrol stations are supposed to provide these charging stations to the customers in the customer parking areas. Fast Charging Act is a separate act which is actually focusing on this 1,000 fast charging hubs, supporting that across the country. This budget, this decent budget has been allocated to this. The other important aspect is that we can notice is that these charging stations have to be equipped with these type 2 connectors. If it is less than 3.7 kilowatt, higher power ratings should have the CCS2 connectors. And the important point, other important point is EV users should be able to charge their vehicles and pay electricity to the publicly, through this at all the places, so that EV roaming that Professor Pablo was talking about is being already explored and implemented in Germany in this particular case. Grid integration of EVs in Germany, even at the residential charging, they have a decent margin where they can add up to 11 kilowatt chargers without need for grid upgradation. There is the other issue is that other important aspect is that these regulations that have come in place recently is that during these EV chargers, be it DC or AC, they, particularly DC here, are supposed to actually provide should have a capability to provide direct power support to the distribution system and the grid. And there has to be this volt-to-var characteristic feature where they can actually control the voltage through volt-to-var or power factor control or the other controllers, and should maintain their power factor within the set limit. So therefore, the other requirements are HVRT, LVRT. So these are very advanced requirements that the Germany has set for these EV chargers, particularly these DC fast chargers that are being put up or are in place in Germany. Denmark, one of the pioneering countries in EV charging infrastructure, particularly when it comes to the integration with the grid, the support services that it can provide to the grid. This is already commercially implemented in Denmark. The electric vehicles are participating in the electricity market. They can actually provide the ancillary services to the grid in Denmark. This is a step beyond, I would say, that these are the features, the control capabilities that EV chargers must have before they are actually allowed to connect to the grid. This is a lot of them is similar to the renewable energy plants. So it means these actually electric vehicle charging infrastructure should be able to not only just connect to the grid, but also support the grid, should have at least the capability to support the grid. And then as and when required, the grid operator or distribution system operator may actually ask for that. Norway is also another important country which has a history in this EV integration, where there is a lot of EVs that are being up, as I showed in one of the slides earlier. the EVs that are being added are actually much faster than the EV chargers are being added to the country. You can see here, particularly this aspect, the average power load added to each household is, if it is 5 kilowatt, then 30% of the transformers can get actually overloaded. So this actually gives an indication of that there is a need to look into this, how it can, potentially it can lead into the congestion of the distribution system, and how, let us say, through smart charging or through other means we can actually, address those issues. Sweden, another very important country when it comes to EV charging infrastructure. This is one of the innovative, future technologies, charging technologies that is being, implemented here. Wireless charging, where over a stretch of 1.6 kilometer, these EVs can actually charge over the load. They have to be certified and registered, and charge their vehicles through this wireless charging. China, which is aggressively adding the charging infrastructure to their grid, is one of the very interesting country where these developments are happening quite at a faster rate. So I would like to bring quickly to this important point to the notice that the State Grid Corporation has a target of to deploy 300,000 EV smart charging stations as a part of the smart charging network. So they are, as I showed in one of the slides, they are adding rapid, ultra rapid chargers quite fast, and also they are focusing quite significantly on the smart charging when it comes to the EV charging space. Electricity demand and utilization factor, I think in the interest of time, I would have to skip this. We'll be sharing anyway later on this study, these presentations. So in addition to the reports that have been released today, we have two very important reports that are on the way. One is the status quo of electric vehicle charging infrastructure and grid integration in India, where we are talking about various aspects of grid integration of electric vehicles in India, gap analysis in the existing charging infrastructure and regulations, and other aspects. And the other important is, so we are targeting this to be released in August, and the target date for the fourth report, which is very important report that will come out of this study, is gap analysis and recommendations for EV integration in India. So with this, I would like to conclude my presentation. There are a few of the conclusions. Fast charging is being preferred and is being added more and more in public charging. Even in the residential charging, wherever there is a margin for adding fast chargers, that is happening because of the technology development, that in terms of battery technology and EV technology itself. Rapid and ultra rapid, as I mentioned, is being aggressively added over the past few years. Several EV-rich countries have implemented grid support services, both at the commercial implementation level, and several demonstration projects and pilot projects have been conducted. Denmark, Netherlands, Germany have released grid connection requirements. As I mentioned, a very important development, which is actually going to be a good learning for the other countries and can be utilized by the other countries, particularly in this case, India. Smart EV charging is, as I mentioned, is one of the key focus that is on these countries, and then EVs are being utilized to address the renewable energy integration. I'm sorry for shooting my time. So we will be extending our session by 5 to 6 minutes, and I hope that is fine with all the participants. So now the next agenda point is, I would request our international partners to give a brief comment, remark from their end on this study. So I would like to request Professor Lena, who is actually one of the well-known expert in UK for this and at the international level in the EV space, and she has done a wonderful work in the EV charging infrastructure and it is grid integration. Over to you, Lena.
Thank you. It was a great pleasure to be involved in this project, and I would like to congratulate the team for their great work. It is clear that this is a very comprehensive report with valuable findings from the global review of policy, regulatory aspect, relevant project deployment, and grid integration of electric vehicles in all these countries. I'm also confident that this study will help the transition to decarbonization of transport through electrification and the deployment of the associated infrastructure. It was coming clear from this report that policy and regulatory aspects are crucial in the progress of the decarbonization agenda, along with standardization. This was mentioned quite clear by Pablo. But it is important, in parallel, the decarbonization of the energy sector and the charging of electric vehicles, preferentially from renewables. Because if we are not achieving this in all the countries, we are moving the emissions from one sector to another. But it is clear that all the recommendations will open important research in the Indian context for achieving this required technological advance in transport decarbonization agenda. This is quite a difficult sector. And as I said, it is important not to move the emissions from one sector to another. So congratulations for all this great work. And as I said, definitively this is very useful in the Indian context, but also in the global context, because all the information that you extracted for these countries are definitively an important read all over the world.
Thank you, Leana. Thanks a lot. Thank you so much for your useful inputs. So I will now request Professor QA from DTU to say a few words about the study.
Yes, yeah, Zakir, thank you very much for inviting me for this launch event, and also it's a great pleasure to be part of this project. And so I also would like to congratulate the team for the excellent work. It has provided a very comprehensive review of the development of electric vehicle integration into the power systems, especially focusing on the challenges and also opportunities for the EV integration. So certainly we will see some challenges from the distribution system operation perspectives. It will increase the demand and also increase the imbalance in the distribution systems. And we have to come up with some solutions to deal with it. And there are different options to deal with the congestion problem caused by EV integration, and also to have control schemes to deal with imbalance issues. And in the meantime, the EV electric vehicles are flexible resources to achieve the future carbon neutral energy system. So we could use this kind of resources to provide the very much required ancillary service, like the flexibility to deal with frequency issues in the future, low initial power system, and but there's some challenge how we could utilize these large resources and coordinate them, and also the cybersecurity issues. We have to be very careful about it, and also, yeah, I think this project is great and also has provided very great results, and I look forward to the next step of this project. Thank you.
Thanks, QA, for the inputs. In the interest of time, I will skip Pablo because he already spoke in the presentation. So we'll move to the final, agenda point. That is the concluding remarks. I would request Dr. Indradeep Mitra from GIZ to provide the concluding remarks for this event. Over to you, Dr. Indradeep.
Thank you, Zakir. Good evening, all, ladies and gentlemen. A very good evening from New Delhi, India. So we have appreciated the engagement that you all have participated and graced this event, although we are overshooting a bit, but I hope this is not a problem. The rising number of electric vehicles at the moment is a result of various policy measures undertaken by governments to transition towards cleaner and rather sustainable forms of energy for transportation, as well as stringent CO2 emission standards and norms. At the same time, some growth and significant, not some, but significant growth in installed power capacity of renewable energy, that signifies that the world is moving towards decarbonization of the power sector. So in this context, over 20 countries now pledged actually for, I mean, they have certain electrification targets or normal internal combustion engine based vehicle ban. While I think 8 or so countries in the European Union have announced net zero pledges already. So in this overall macro concept, of course, India is also a part of it, and India is really going towards electric mobility and cleaner forms, decarbonized forms of mobility in the country. This particular event today has been proactive in coming to grips with important developments taking place around the world regarding charging infrastructure and its integration with electricity networks. I hope that in this 1 hour of time, we had actually gained a better understanding about the challenges as well as the opportunities lying ahead. Pablo said many times about both challenges as well as the opportunities we have in this. The objective, of course, is not only to provide electricity for charging the batteries of the vehicles, but also to support several other aspects where charging infrastructure as a whole can act as an opportunity. You will get all the information in much more details in the reports. Is voluminous reports. In these two reports together is almost 500 pages. So a lot of information, valuable information, have been compiled and presented. I hope all of you get benefit out of reading that. One thing I need to say that flexibility aspects of electric charging and discharging must be used for smooth grid operation. The opportunity of a meaningful sector coupling between energy and e-mobility needs to be explored further in the Indian context. And that's the exact reason why our upcoming reports, number 3 and 4, on India-specific situation and recommendations for action will be important for many of you. I personally wish to express my gratitude to all of the speakers and the participants for coming and participating in this event. I'd like to extend our sincere thanks to our Ministry BMU for funding our NDC-TIA project. Our deep sense of appreciation to the study team from IIT Bombay, Florence School of Regulation, DTU, and University of Cornwall and University of Cardiff, led by Professor Rangan Banerjee and executed by Professor Zakir Hussain Rathar. Thank you very much and have a pleasant evening. Thank you.
Thanks a lot, Dr. Indradeep, for concluding remarks. With this, we would like to make the final announcement before we close the event, is that we will be uploading, as mentioned earlier also, all the recording, presentations, and the response to the questions over the web links that we have given. We'll be pasting a web page link here, over which we'll upload all this material, as well as the other links that have been provided earlier. We'll be uploading all the material over that after a few days, and in addition to that, other reports as well. Earlier material and the reports, the recordings of the events are also uploaded over this website. So with this, I would like to thank all the participants for taking their time to participate in the event. Thank you so much for joining this event. Thanks a lot. Have a nice evening. Thank you.